Hello everyone, welcome to csecmathstutor.com. In today's video, we are going to be looking at analyzing quadratic graphs. By the end of this video, hopefully, you should learn how to use the quadratic graph to solve an equation or to solve equations related to it. You should be able to find the minimum or maximum value from the graph and also to write down the axis of symmetry. Also, you should be able to calculate the gradient at a point. You should also be able to locate values of x for which the function is greater than or less than 0 or any other number, and to solve two equations on the graph. That is, to find a solution of two graphs that intersect on your graph paper. Let's begin by looking first at how to solve equations related to the graph. So let's say we're given this function y equal x squared plus 2x minus 3. This is the domain of the function. It is written as -4 is less than 8, less than or equal to x. X is less than or equal to 2. This is our domain. We want to write down our range. The domain is that set of numbers that runs on the x-axis. So if you look here, you will see that -4 all the way over to 2. That's what this is saying. That's your domain. Now we want the range. The range is the measure on the y-axis now. So we want to see the lowest value that our graph reaches on the y-axis and to see the highest number that it also reaches on the y-axis, and that is our range of values. So we write our range as -4. Since the lowest value is -4, we use y, and because the range is measured from the y-axis, and we use our highest number at the top. So it runs from -4 to 5 on the y-axis, and that is our range. For what values of x is f of x equal to 0? All that this means is you need to look at your graph, see where the graph intersects with the x-axis. The graph intersects with the x-axis here and here. And all that you need to do is to write down those two numbers. So for what values of x is f of x equal to 0? It's equal to 0 where the curve intersects with the x-axis here and here. So our solutions are x equal -3 and x equal 1. For what values of x is a function equal to -3? To answer that question, we need to put a line through -3. So you can use your ruler, make a broken line through -3. Here's -3 on your y-axis. And then we ask ourselves, where does that line intersect with the curve? So this line that we just drew, y equal -3, it intersects with the curve here and here. And all that we need to do is to drop a line to our x-axis to see what the corresponding values of x are for those two intersection points. And the values are x equal to -2 and x equal 0. And those are the solutions. Let's look at a similar example. Here's our function, f of x is equal to 2x squared plus 5x minus 3. We want, first of all, to talk about what does it mean to use the graph versus an algebraic method. Now, if the question says use the graph, you need to actually use the graph to solve the equation. So for what values of x is f of x equal to 0? It's equal to 0 here, where the graph crosses the x-axis. So our solutions are x is equal to -3 and x is equal to 0.5. Now, sometimes the question may be written as, instead of saying f of x equals 0, the question may be written as, what are the values of x for which 2x squared plus 5x minus 3 equals 0? And the student looking at this question sees a quadratic equation and immediately goes to use the formula or factoring if it can be factored. If you do this, you will not get marks even if you get the question correctly, because the question had specifically said use the graph. So please remember, in a situation where the question says use the graph, you should not use an algebraic method at all. All right, so for what values of x is f of x equal to 4? For that, we need to put a line through 4 on our y-axis. This is the line y equal 4. Let's label it y equal 4. And we need to say, where does the line y equal 4 intersect our graph, our quadratic graph? It intersects it here at this point. So we drop a line down to our x-axis. It also intersects it here. We drop another line down to our x-axis. And we can see that our two values are, when f of x is equal to 4, our values are x equal negative 3.5 and x equal 1. Let's now talk about the minimum and the maximum values. The minimum value of the function, as it suggests, is the lowest number that the graph reaches. In this function, the lowest number that the graph reaches is negative 4 measured on your y-axis. So your answer there is y equal negative 4. It's as simple as that. Write the equation of the axis of symmetry. The axis of symmetry, if you remember, is that line that passes through the middle of the graph. And here is the line that passes through the middle of the graph that makes that half of the graph identical to this half of the graph. To get our axis, we just simply write the number that it passes through. The number there is negative 1. It says the equation of the axis, so we write an equation, x equal negative 1. Note also that this question, write the equation of the axis of symmetry, may also be written as at what value of x does f of x have a minimum? It means the same thing. So whenever you see it, realize that those two questions are asking the same thing and it's the same answer. You wouldn't be asked to do this in the same question on a CXC paper. The person writing the question may either use this version of it or that version. However, they mean the same thing. Now we need to state the coordinate of the turning point. We have looked at this before. The turning point is this point on the graph where the graph turns, also called the vertex. The vertex is made up of two numbers, the x number, y number, where the x number is your axis and the y number is your minimum or maximum. So in this question, to write the coordinates of our turning point, the minimum is negative 4 and the axis is negative 1. So writing it in the form xy, we have negative 1, negative 4, and that is the answer to our turning point, the point at which the graph turns. Let's try that again with a different question. Now, what is the maximum value of f of x? In this case, the number we can see is slightly above 6. On a better graph paper, you could estimate it better, but this one looks a bit like 6.2 or somewhere there if you should want to estimate it. So your maximum here, I'm going to estimate it at 6.2. It's a little bit above 6. So we wouldn't write 6 because it's above 6, but not sure exactly what it is based on how the axes are numbered. So I'm going to write 6.2. The equation of the axis of symmetry, this one, again, we need to estimate it, but we can see that it falls directly between 1 and 1.5. And that number that comes directly between 1 and 1.5 is x equal 1.25. That number is our axis of symmetry. This question means the same thing, it's just a different phrasing of it. X equal 1.25. So you may either be asked at what value of x does f of x have a maximum, or you may be asked what is the equation of the axis of symmetry. And having these two values, we can now write down our turning point. Remember, our turning point is the point at which the graph turns, right here, the vertex of the graph. And once we know that, we can simply write the x value, y value, and the x value here is 1.25, and our maximum is 6.2. This is our turning point. Continuing, if we want to calculate the gradient at a point, the question says calculate the gradient at the point x equal 2. Notice the point x equal 2 here, and the gradient is drawn so that the line touches this line. It's called a tangent, and it's drawn touching the curve at the point x equal 2. To find our answer, what we need to do is to put a right angle triangle on this line. So what you should do is find a clean point along that line and draw a right angle triangle on it. Has to be a right angle triangle. Once you do that, you can look at your rise and your run. The gradient is equal to the rise over the run. So we look at our rise. Our rise is each centimeter on this graph represents 1. So our rise is 1, 2, 3, 4, 5. So our rise is 5. Our run is each 2 centimeters here represents 1. So 2 centimeters there, that's 1. Another 2 centimeters, that's 1.5. So we have 2.5 there. Dividing 5 by 2.5, we get 2. So the gradient at this point where x is equal to 2 is 2. All right, let's try that again with another question. If we want to find the gradient again at the point x equal 2, here is a point x equal 2. We need to locate that on the graph. That's right here. And in this case, we were not given a tangent, so we need to draw our own tangent. To draw your own tangent, you need to get a ruler. And what you do is that you try to isolate the point where the tangent should be drawn. You need to push your ruler around, push it from inside the curve, like that, until you actually isolate your point. And once you isolate your point, there we go, that looks good. You draw a straight line through that point. Notice when you draw your tangent, it should not be that you're drawing the line through here. The tangent should touch the curve at one point. So I'm going to do my best here to let it, here we go. So that when I draw my tangent will be touching that point and that point alone. There. Exactly like that. That's actually a little bit on the inside. I probably should push it up a little bit more. And just a little bit more. And draw that line. Okay, let's use that one as it is. It's giving a little bit of trouble here. So once you have that, you need to put a triangle on that line. So we're going to put a triangle on that line. I'm going to start here and run my triangle across here so that we have it. Here's a right angle triangle, and now we need to decide on our rise and on our run. So remember the gradient m is your rise over the run. You have to draw a good tangent, otherwise it will throw off your answer. However, from knowing how CXE operates, they will not be penalizing you very much with the tangent. It should be drawn as neatly as possible, as closely touching just one point on the curve. However, once the student has the idea of what they should be doing, markers are generally not as brutal in marking the question that way. And what we're going to do now is find our rise. So our rise is 1 centimeter to 1 unit. So we have 1, 2, 3, 4. I'm going to estimate that as 4.3. And our run is, each of these is half a centimeter. So half, 1.5. So 1.5. And once we do our calculation, this almost ends up being 3. It looks like 2.8, 2.9. I'm going to estimate it at 2.8. You could actually use your calculator and divide it out. So we can have 4.3 divided by 1.5, and that will give us 2.86. So 2.86 or 2.9. Again, when you do these things, you will often get an estimate of what it is. and that would be your gradient. However, you need to make a point here about the number that we just found. Because our gradient line, our tangent line is heading in this direction, our gradient is not a positive number. As in this case, in this question, the tangent line is running in this direction, which means that your gradient is a positive number. In this question, the tangent line is going that direction, which means that your answer actually is negative 2.9 or negative 2.8. All right, so please remember the direction of the line has an impact on the sign of the gradient. We can now look at values of x for which f of x is greater than 0 or less than 0. What does this mean for what values of x is f of x greater than 0? What it means is you want to find the section of the graph that is above the x-axis. So what section of this graph is above the x-axis? Well, this section is above the x-axis. Also, this section is above the x-axis. So for what values of x is f of x greater than 0? All the values of x starting at 1 upward, so 1, 2, upward, are going to give you a positive value on the graph. And all the numbers starting from negative 3, negative 4, they're going to give you also a positive number on the graph, which means that we can write our solution as x is greater than 1 for all the numbers in that direction. And we can write our solution here as x is less than negative 3 for all the numbers in that solution, that direction, going this way. So our answer is the union of these two. So we write x is greater than 1 union x is less than negative 3. And that is the answer to this question, where we want to find the values of x that give us the part of the graph that is greater than 0. For what values of x is the function less than 0? The function is less than 0 when you have negative numbers. So if you look at this part of the graph, all these numbers on this side of the graph are negative numbers. And this section of the x-axis defines all of them. So all the numbers between negative 3 and 1 give you a value that is less than 0. So we can write that in an interval format. So we can say the values of x for which f of x is less than 0 start at negative 3, and they go all the way up to positive 1. And this becomes the solution for this. Let's try this idea again with another question. Here, we want to find the values of x for which the function is greater than 0. All the values up on this side of the graph, everything up here is positive. This part of the graph is above the x-axis, so everything is greater than 0. So what x numbers give us that? The x numbers that give us that start here and stop here. So they start at negative 0.5 and they go all the way up to 3. So those x numbers, if you should plug them into the function, you're going to get a positive number here on the graph. Now let's ask another question. For what values of x is the function less than 3? Well, for that we need to draw a line through 3. So let's find 3. 1, 2, 3. If f of x is less than 3, then the values of x that give us those answers are here and here. Now, everything starting here at this point, starting here at this point, we have numbers that are less than 3. So everything on this side of the graph, let me mark it, all the numbers on that side of the graph are less than 3. And everything on this side of the graph, they're also less than 3. And those numbers start right here at 2.5 and right here at 0. So we can say every number starting at 2.5 going above. So x is greater than 2.5. And at the same time, every number starting here at 0 go in that direction. X is less than 0. And this combination of values answers this question for what values of x is f of x greater than 0, greater than 3. So essentially what it's asking is just that you look at your graph and you see the region that is being talked about, and you look at your x-axis and see what x values are giving you the numbers. So for what values of x is the function greater than 0, what x values are giving you value on the graph that are positive or bigger than 0. And in this case, what x numbers give you values on the graph that are less than 3. Put a line through 3. This line would be y equals 3. And you look at it and you see what x values produce values on the graph that are less than 3, and you just write those down, and those become your solutions. Finally, we're going to look at how to solve two functions on the graph. Now here we have the function 3 minus 2x squared plus 5x, and the function 3x minus 1 being g of x. So if we want to solve the function f of x equals g of x, again, I'm going to write it out. Sometimes the question may just write it as 3 minus 2x squared plus 5x equal 3x minus 1. Do not be tempted to use the algebraic methods to solve it. So we are supposed to use the graph, and all that we're supposed to do in doing that is locate the intersection points. Pretty simple stuff. So once you know what it means, then you won't have to stress yourself out to either use the formula or factor it out to get the answer. And even if you did it anyway, you still wouldn't get the points. So remember, locate the intersection points. Now, the two graphs intersect at this point. The x number is 2, and the y number at that point is 5. So we have at 2, 5, it works. And here we have -4 on our y and -1 on our x. Also, that's the other point, -1 and -4. So because the question is asking for the values of x only, then we can write down our solution as x is equal to 2 and x is equal to -1. If the question had asked for the solutions, and that would quite be a different thing. So our x values are these, but if the question had asked for the solutions to the equation f of x equal g of x, that's a different thing, then we need to include all four numbers. X equal 2 when y is equal to 5, and x equal -1 when y equal -4. But like I said, this question said what are the x values, so you write down your x values. This is the solution. However, if the question had just said what are the solutions instead of specifying x values, then you need to write all four of these answers, 2 x answers and 2 y answers. Let's look at the last question for this. Here we have it again, the function x squared plus 2x minus 3. And we want to see where that function is equal to the function 2x plus 25 over 7. So where are those two functions equal? They're equal at this point where they intersect, and they're also equal at this point where they intersect. And what we do now is that we drop our line down to the x-axis and we see what those coordinates are. So it says solve the equation. All right. We're going to solve the equation. The coordinates are this one. This is 1.5 and 2 on the y-axis, and the other point is -2, -3. Again, this question had asked for what are the x values, or what values of x. So the x values are 1.5 and x equal -2. Like I said before, if the question had said what are the solutions to this equation, the total solutions would be x equal 1.5, y equal 2, and x equal to negative 2, y equal to negative 3. I hope that this video would have been useful to you. We went through quite a bit of information. If you're doing CXE and you would like more videos like this, please subscribe, and as soon as the videos become available, you will be notified. Thank you for watching, and continue working hard at your exams.